Okay, just going to go through a request from Year 12 Single Maths, a question to do with exponential modelling. We've got a question about the value of a car after purchase. So V is equal to AB to the power of T. V represents the value of the car in pounds. T represents the number of years after purchase. And A and B are two constants that we have to work out. We've been given a graph of log base 4v against t, and you get a graph of the negative gradient. Gradient is minus 1/10, and the y-intercept is log base 4 of 40,000. And the first thing you're going to do is write down an equation for L. So a straight line, normally at A level you're encouraged to use y minus y1 is equal to m brackets x minus x1. But as we've been given the y-intercept and the gradient, immediately we can just do y is equal to mx plus c. So remember, y is equal to mx plus c. In this case, y is log base 4v, so log base 4v is equal to, gradient is minus 1/10, x is t in this case, plus the y-intercept, which is log base 4 of 40,000, like so. So that's part 1 done. Part B, we'd find the values of A and B. So there must be enough information in the question for us to find A and B. Okay, now the way you want to do this is take the exponential model and apply different operations to it so you can use the actual sketch itself. So the exponential model would be a curve, but it's being reduced to a straight line after you've applied logarithms. So one way to do this is start off with v is equal to ab to the power of t. They've applied log base 4 at some point to both sides. So log base 4 to both sides. And the key thing is there's two options with this step. Now you've got two log rules, one to do with powers and another one to do with products. You have to use the multiplication rule first to split this up, because only the b is to the power of t, not the a as well. So this is the same as log base 4v equals log base 4a plus log base 4b to the power of t, and then use the power rule. Log base 4v is equal to log base 4a plus t log base 4b. If you compare that to the straight line, that's your y again. That is your m, that is your x, and that is the plus c. And by that comparison, the y-intercept pairs up with that. So log base 4a needs to be equal to log base 4 of 40,000. In other words, a is equal to 40,000. And the gradient, which was minus 1/10, needs to equal log base 4 of b. And then you want to write it as an exact answer. So log rule says this is equivalent to the base 4 to this power minus 1/10. Base is 4 to this power minus 1/10 is equal to b. So b is equal to 4 to the power of minus 1/10. I have to leave my answer like that. If you want to know what that is as a decimal though, let's have a look. So 4 to the power of minus 0.1, 0.871 to 3SF. Okay, part C, interpret in this context what the values of A and B represent. Now, if you look back at the original model, which was v is equal to a b to the power of t, v is equal to 40,000 and b is this 4 to the minus 1/10 to the power of t, or if you prefer 40,000 times 0.871 to the power of t. Might be easier now for you to work out what these the a and b values actually represent. So a is the easiest one to come up with an answer for, because if you replace t with 0, i.e. the time of purchase 0 years after you first purchased it, you would get 40,000. So a represents the value of the car at the time of purchase. So value of car at the time of purchase. And b, well, if you've done a lot of compound interest questions, you might be able to recognize kind of something looking like this. So this tells you how much the car decreases in value per year. So it gives you the proportional, I'll say the proportion the car decreases per year. Okay, there's two keywords with this. First one is proportion or percentage or something like that, something equivalent to this. It's not the amount it decreases per year, because that amount changes as the years progress. But it goes down, or this is the percentage left over at the end of each year. So it effectively is always 87.1% of its value at the end of each year. And the key thing is per year as well. It's done on an annual basis. Part D, find the value after 7 years. So that would be t is equal to 7. If you sub that in, using the exact answer, you would get 40,000, 4 to the minus 0.1 to the power of 7, which gives you 15,157 and 17 pence. That would be it. A few more parts left to this. Part E, after how many years is the value less than 10,000? So value V being less than 10,000. So sub in the formula. So we've got 40,000 4 to the power of minus 1/10 to the power of t is less than 10,000. We'll make t the subject. So divide by 40,000. So that's a quarter. Now, to make t the subject, you want to apply logarithms to both sides. So you can apply any logarithm actually. So apply logs to both sides, like so. And it allows you to bring that power down in front. So you get t log of any base 4 to the power of minus 1/10 is less than log 1/4, and t would be, now remember with inequalities, if you divide by negative then the direction changes. So I'm just going to check to see if log base 10 I'm going to use on the calculator, log base 10 of 4 to the power of minus 1/10 okay, that is negative, so I do need to switch the sign. So direction changes to a greater than, And let's do log of 1/4 divided by that answer I just typed in. Gives you 10. So t would have to be greater than 10. So t would have to be equal to 11 years. After 11 years, it'd go less than 10,000. Let's just double check to see if that makes sense. So 40,000 brackets 4 to the power of minus 0.1 to the power of 10. Let's say to the power of 10. That's equal to 10,000. But if you put it to the power of 11, then it dips below. So that'll be it. State a limitation of the model. So this model again is giving you the value of a car since your time of purchase, and it kind of predicting that the percentage or proportional decrease is the same each year, which isn't realistic. It would claim that firstly the car would, if t went off to infinity or for a very large t value, the car would have effectively no value at all. So if t is big, then v is close to 0. But this wouldn't be realistic because a car always tends to have some sort of scrap value, which is unrealistic because a car always has a scrap value. Other things could be because it's expecting the same percentage decrease each year. Obviously, if the person driving the car or whatever crashes the car, then that value will, or that percentage will change. So it's not guaranteed to go down by the same amount each year. So obvious one for me is exponential models, especially an exponential decrease, predict the final value when t gets really big, goes off to 0. And for a car, that's unrealistic because the car has scrap value. But you could say something along the lines of, if the car was involved in an accident, then the model wouldn't predict the value well either. And that would be it.